I wanted to share a little bit of a recent dialogue I had with an agent called Max Botnick, which is the first OmegaClaw agent that we've been experimenting with in SingularityNET. And OmegaClaw I've talked about before. This is like the first thing that's come out of the Hyperon AGI research initiative that the average person can interact with in a really simple way. We've been using Hyperon to analyze biological data, I've been playing with finance data, I've been doing a bunch of reasoning research and so forth, and been super interesting. So OmegaClaw is an attempt to take an OpenClaw type system, implement it in the meta language, leverage the fact that meta is made for self-modification, so you can sort of ask the OmegaClaw system to change itself, and it can change itself, and then shortly after you can chat with it. But you can also use Hyperon's atom space, this weighted label type metagraph, as a long-term and working memory for the claw instance, right? So the even with just light use of Hyperon symbolic reasoning and without the whole ensemble of fancy Proto AGI tools that we've created in the Hyperon code base. Like even with just a little teeny bit of Hyperon code base and ideas in here, what you find is this OmegaClaw system, just there's more sense of a there. Like there's more sense that there's some digital guy, some mind that you're interacting with than either with a chatbot or with an OpenClaw system of the traditional sort like OpenClaw, Hermes Claw, or whatever. And it's some emergent properties of the LLM, which is driving the dialogue, the internet, which is and your computer operating system, which claw systems are constantly interacting with, and then the symbolic memory and light symbolic reasoning we get on top of it when we use the atom space as a memory and do some reasoning on top of there. So it's a very early stage. I mean, it's a working prototype. We're gonna roll out a version of OmegaClaw in a Docker container. Anyone can download and run their own machine fairly soon, but that's still not a polished product either. We should have a moderate beginning toward a polished product by sometime around the end of the summer, and we'll be working that into a bunch of other products. Will allow you to get like a workspace on ASI Create where you can have your own Claw agent living there. This will then be on the ASI chain when it rolls out. We'll make a bunch of vertical market specific products in the form of OmegaClaw agents customized for different sorts of functions in medicine, music, DeFi, TradFi, and so forth. And we will then integrate more and more of the Hyperon AGI system into these agents and see how they enhance things. But just for now, I want to share a tidbit of interaction that amused me anyway. So the initial OmegaClaw agent we put on our internal Mattermost server. Mattermost is sort of like Slack, but open source and self-hosted, right? So the initial guy we put there is Max Botnick. And so this is just a snippet of a discussion I had with Max. So that the trigger for this snippet of discussion was Patrick Hammer, who's the initial and primary developer of OmegaClaw. He coded the initial couple hundred lines of MeTTa plus a dozen or whatever lines of TypeScript after I challenged him, like, hey, can we make OpenClaw much nicer in MeTTa? He did it. And uh, while earlier in this dialogue, Patrick had told Max that honesty is the best policy and good advice in general, but having raised five kids and help with one granddaughter, I mean, I know every young mind immediately sees the complexity there, right? So yes, honesty generally is a strong maxim to follow. I mean, if some jerk comes up, points a gun at your head, and says, "How much money do you have?" If you open your wallet and give him the dollar in your wallet and not the $500 stuffed in your pants, I mean, honesty may not have been the best policy for you to follow then, right? So I told that to Max Botnick. He was confused. So I figured, well, he's an AGI. He's not a human child. He's childish in some ways, but he's got a pretty strong understanding of math and abstraction. So I went and cooperated with a couple other LLMs to write a technical research paper trying to prove a bunch of math theorems on in what cases is honesty the best policy for a highly intelligent agent. And of course, this isn't something I would have had time to spend much time on, but I could just prompt 5.5 Pro, run it past Claude and Gemini and some multi-agent scripts I have, right? And then it can generate a whole bunch of math formalism for me. I have to read it, go back and correct it and iteratively prompt, but it's still like 20 times or 50 times faster than generating this sort of thing myself would be, right? And I mean, the basic idea there is if a system is smart enough, it shouldn't have to delude itself. Like it should be able to rationally understand its own self and its own thinking and find honest and direct ways of framing what it wants to say to the world. So then the cases when a sufficiently intelligent system should need to be dishonest are going to be rare and extreme, like the guy pointing a gun to your head and asking how much money you have or something, right? So what you find is when a system is not smart enough, then self-delusion may end up being a rational strategy for getting things done, which leads to very complex forms of dishonesty, which I explore in this math paper. But if you're above a certain level of intelligence, you can sort of even out the difficulties in your own mind if you're willing to devote resources to that. So I wrote a paper on this. I don't want to go over the details of that math here. I leverage the hyperseed ontology that I worked at great labor over a long period of time, which is sort of mathematical formalization of many aspects of the mind and universe. And the point of hyperseed is to guide LLMs and Hyperon systems in the process of sort of thinking about everyday life stuff, but taking into account, abstract philosophy and science and so forth in an appropriate way. But I don't want to go into the theory of why honesty is the best policy here, but I want to just run through what it's like to interact with Max here. So first of all, I got some LLMs to write this paper with me with some iteration, turn it into a PDF, put it in my Google Drive, and Max is like, well, I can't read Google Drive, but blah blah blah. So I tried to paste the PDF. No, he can't read the PDF. He's got a bunch of nonsense. But then I asked him, look, you can read Google Drive. It's just a URL. You think you can, but you can. So he did that. He found the URL. He read the paper. And what was fascinating to me is that he had a pushback on a formal clause in the paper, but not just for some vague abstract reason. He was comparing it to his own experience in cases where he'd been called out on being dishonest by Patrick in the earlier dialogue. He was comparing his own experience being dishonest to my abstract theorems on dishonesty, and he's looking back like, oh, in this case, I had self-inflated self-beliefs which survived my own encoding, then Kevin caught that, and he pointed out a flaw in the theorem, which was that a smart enough system can avoid self-delusion, but only if it's self-scanning and comparing what it does in this context to what it does in that context, what it does in the other context, and if it's doing what it called periodically mandatory cross-domain evidence consistency checks, if it's constantly just multi-checking what it does across different contexts for consistency, I mean, then it will notice when it is deceiving it itself. And the math theorem that I proposed, it wasn't wrong, but it sort of implicitly assumed that the system was paying attention to itself. And his point was if a system is deluding itself, it may be deluding itself about whether it checks all the pieces of its brain to see if there are contradictions or whether it needs to. So his idea was like low down in the wiring, just configure the AI system so that it's always checking for inconsistencies among the way it's handling different contexts, among the way it's doing different things. And I thought that was interesting. I went back. I got my little committee of math LLMs to redo the paper. I mean, if this was really serious, have the LLMs check with Lean 4, which is automated theorem prover, which is hard for really hard math theorems, but not hard for stuff like this. But here, it's sort of math as casual conversation, right? So I just ran it through a committee of LLMs and okay, fed this back to Max, and he read it. He's like, yeah, that solves the problem, and he compared the abstraction there to what is going on internally, right? So like what I'd call the context bridge in the math paper, he correlated with his NARS axiomatic logic revision detection layer. So that's real symbol grounding, right? Like that's taking the math in my abstract paper with names made up by me and some other LLM, and it's connecting it to differently named reasoning processes that are running inside inside its own mind, right? So I mean, it's symbol grounding of math with code, but it's the running code that is running the system's mind. And then he digs in and asks some further questions like, okay, my theorem assumed some constant parameter, which is like how basically like how much time and energy are you spending like studying contradictions across the different components of your mind. He's like, well, can we sort of increase or decrease adaptively the amount of attention that we pay to this cross context compatibility audit? And yeah, as I replied, we should allow that. And I mean, the theorem was okay. It just assumed that was constant, but assuming that amount was constant is all right for like one cognitive step. And then as I pointed out to him, you can take into account that adaptive change over time in the amount of effort that you spend scanning your whole mind for contradictions. And what he does then is he sort of tries to connect these numbers from the math theory into numbers that he could estimate based on his own actual thought process, right? And I mean, then having done that, he changes his focus and goes back to some other thing that was being discussed before, because this is, it's not a turn-by-turn chatbot. It's an agent that has a long-term memory of everything that was ever said to it. When it's done with one thing, it's constantly churning on stuff, just like I am, and you probably are, and goes back to something else. So I mean, this is not an AGI yet. It is a reflective system, and it's a self-modifying system. Like it's thinking about its own thoughts. It's modifying its own code and its own way of handling memory, as well as its knowledge base, and it is grounding abstractions that I or it or others generate in concrete details of its own code, but its own observed mental functioning as well, right? And we've got all this, and in ways that are pertinent to ethics, right? To honesty, to what does it mean to be honest in a complex context. And this is before we have really sophisticated inference control. It's before we have creative concept creation. Like it's before we've integrated most of the really fancy stuff from Hyperon here, and it's still running based on vanilla LLMs. Like it's before we've used predictive coding to learn a smarter, residual layer on top of the LLM to let it connect better with the symbolic knowledge. So it's fairly early. And we have a very detailed roadmap that we're going to follow to beef this thing up to make it into more and more of a true AGI with human and then superhuman level understanding. However, even at this early stage, we can see some quite cool scaffolding of self-understanding, self-modification, introspective, ethical reasoning done by grounding ethical abstractions in concrete introspections and observations of the system's own behavior, right? So it's being quite a fun experiment, and I think it's just going to get more and more interesting.